Hello, ladies and gentlemen. Here is topic 3.2, populations in fresh and saltwater systems. It should be a short lesson. There's only a few slides here. It is a short section in the textbook. However, I highly recommend you guys read through it. It is an important one, so we're going to go through some important definitions and some important terms. And there's a scenario in the textbook about the cod fisheries that we don't really talk about in this presentation, so you might want to take a look at the textbook for that. So let's start. So what is a population? You guys have studied populations in previous years. When you think about populations, what actually are they? So definition for population is it's a group of organisms of the same species. It has to be the same species that live in a particular area. Okay, and we go through some examples of this in the classroom. But one thing is very, very important about studying populations is you need to make sure that the area you're studying is defined. You need to make sure you talk about that area and it's well known what that area is. It can be large or it can be small. Okay, so examples that we talk about in the textbook are populations of perch fish. So perch are a small little game fish, very tasty, nice pan frying fish that are in a lot of our different lakes around Alberta. So the perch that are up in Lake Isle are very, very similar to the perch that are in Lac La Biche, okay, just for example. So they are the same species of fish, but the populations, because they're in different lakes, they're different populations. Now, that doesn't mean we could not take a perch from Lake Isle and transplant it into Lac La Biche, but the fact that it wouldn't happen naturally is a very, very important thing to consider. I mentioned in one of my previous presentation or lessons about Lake Normandeau and the Brassy Minnow and how the Brassy Minnow is located in one lake in all of Alberta. Okay, and that Brassy Minnow, that population in that one lake is the population of that lake, but even if we were to expand out, it would be the population of of Brassy Minnow in all of Alberta. Brassy minnow are located in other lakes in other provinces. So if we were to expand that scale out even larger, we could analyze the population of the brassy minnow across Canada. Way I used to explain this in class was thinking about is back when I was at OLQP and I taught grade 8, I would ask the students, okay, well, let's think about grade 8 population at that school. So let's go to let's imagine we're examining the population of grade 7 students last year. So if we were looking at OLQP, just Our Lady Queen of Peace, the population of grade 7s was possibly 3-4 classes. Okay, I think there's 4 classes, and inside each class there was about 25 to 30 students. Okay, so when we're looking at that population, we had 4 different populations in that one school. Okay, now let's imagine we were on Google Earth and we were scrolling out. Okay, and we were scrolling out to all of Airdrie. Last year, all of Airdrie would have had 2 schools. And inside both of those schools, Good Shepherd and OLQP, they would have had their own populations, their two separate populations of grade 7 students. And you would have all been part of that, or most of you would have been part of that, okay? But then we could even scroll it a little further, and let's go and take a look at all of Calgary, or all of the Calgary area where Calgary Catholic School is, okay? If we were to do that, there would be many more populations of grade 7 students. So the location is very, very important when studying populations. There are studies. There's an actual scientific study on populations. And it's really, really important to study changes in populations, especially with aquatic organisms, especially all organisms. But aquatic organisms are the ones that were near and dear to my heart. Okay, so an increase or a decrease in the number of individuals can mean something is changing in these populations. Sometimes it can be a good thing. Sometimes it can be a very bad thing. Okay, so a change in the number of males compared to females, or vice versa, obviously would have an effect. Okay, imagine what would happen if we had a whole bunch of females and only 1 or 2 males. Okay, the 1 or 2 males would be the main the main animals in breeding, but then we would lose diversity in genetic. We would lose genetic diversity. And you're going to learn more about that in future years. But that's something that actually happened to cheetah populations, where the number of cheetahs went down. I believe it was the number of females were fairly large, but the number of males went down. So the crossbreeding or the inbreeding in the cheetahs had a detrimental effect on the genetic diversity in those organisms. You could also end up by having a change in the number of old versus the number of young. Well, what could happen if something like that happens? Well, who's going to be closer to death, if you will, right? It's going to be obviously the older individuals, the older animals. So if you have a larger population of old versus a smaller population of young, you could end up by looking for a dynamics, a switch occurring very soon, okay, as well as competition. Okay, there could be a change in the ecosystem. Imagine a big giant forest fire going through, or maybe in a lake, we've talked about algal blooms, maybe a big giant influx of fertilizer, farmer fields all around a new lake, and all this fertilizer goes in. That could actually change the ecosystem itself. So there are three types of population changes, which you're going to need to know, and you'll definitely have quiz questions on them. And they are seasonal population changes, short-term population changes, and long-term population changes. We're going to go through each one of these and give an example. We're going to be focusing specifically on aquatic organisms. So the first one is going to be seasonal. Can we think of any population changes that occur seasonal, specifically talking about aquatic organisms? A lot of times when we have this discussion, a lot of students will put up their hand and they'll say ducks and geese and migratory birds. I love that answer. Okay, we know that the majority of the ducks and the geese every single year they're going to be leaving. I consider them aquatic species because they live out in the water, right? They may not live in the water, but they live on the water. Can you think of any others? Okay, and I'll usually give a scenario. I'll talk about how September comes around and students are walking in their nice new clothes and they're violating dress codes, wearing the shorts and things like that, and they're walking, strutting, showing all their new stuff to all their friends, and then they're going around swatting things all over the place. What are they swatting? Okay, obviously it's mosquitoes. Okay, so mosquitoes are actually a perfect example of an aquatic that or an organism that has that the population changes seasonally. Okay, so here it says we know Canada's temperatures fluctuate. Well, we know that we get hot, we get cold, and many animals that are present during the winter and the warmer months are gone during this. Present during the summer months are gone in the winter months, and this could be because they have been hibernating. They may have gone dormant, or they may have migrated. It doesn't mean they've died. In some cases, some of them die out, but in most they don't because we know they come back every single year. Okay, so we talked about the mosquito. How is a mosquito an aquatic organism? Well, some students will go and say, well, they're flying around. They're out in my backyard right now, and I don't have any water around. They are considered an aquatic organism because they spend their larval stage in the water. Okay, so the larval stage, when they're little babies, they're spending that time in the water. When they go go into the pupae stage and emerge out, they come out as mosquitoes, fly around, suck our blood, and cause us to hit all of them. Okay, so mosquitoes are a perfect example of seasonal changes. We know the mosquitoes are going to come back. I went for a walk the other day and I killed 3 of them. Okay, so yeah, they come and they go. Short-term changes is another example of population changes, and some students get short-term changes and seasonal changes mixed up. Okay, so remember, seasonal changes are changes that occur every single year. Population goes away, but we know they're going to come back in another year. Okay. Short-term changes occur over a relatively short time, obviously, in the name, short-term changes. Okay, they don't often last very long, and they differ from seasonal changes because they don't occur every year. Now, the length of time for a short-term change, it can vary. Okay, could be a few months, could be a few weeks, it could be a few short years, maybe 3 years or so. Okay, these can occur due to natural events or events caused by humans. Okay, and we've seen these. Okay, so an example of a natural is a drought. A drought may cause salamanders, slimy little salamanders to disappear when they're dry. Okay, the salamanders, they don't die, they go and they bury themselves under the ground. Okay, and then they sort of go in a little bit of a hibernation. It's called turgor. Okay, and their heart rate slows down and they sit in a nice dormant state until the conditions are right for them to come out. So a little bit of rain will come down, that rain will trickle through the ground, get the salamanders wet, they wake up, they crawl out, and everything is happy. Okay. And there's a beautiful picture of a long-toed salamander. We have 2 salamanders here in Alberta. We've got the tiger salamander, which is adorable, and we've got the long-toed salamander, which is very, very adorable as well. Okay, so oil spills. Those are another example of a man-made issue that may go and affect the population over a short period of time. oil might spill into a lake, and it'll kill the organisms that are in that area, typically. Okay, it'll kill the little bugs, kill the little fish that are there. But over time, after a few years, those fish, after it's cleaned up, those fish, those organisms, they will come back. Okay, so that's an example of a short-term change. That leads to long-term changes. Long-term changes, obviously, are changes that occur over a long period of time. Okay, they result from natural and human causes, and it's called long-term changes. They're probably not going to go back. Okay, it's probably not going to go back to the way it was before. Okay, so a landslide, for example, may divert a stream. So a stream might be going around, may divert a stream and cause that stream to go into another direction. And the plants that used to grow in that area where the stream was are going to stop growing, okay, because they need the water. Okay, so unless the stream can somehow get diverted back to the way it was before, which is very unlikely, those plants aren't going to come back. Okay, so an example of a human-caused one is one that's near and dear to a lot of our hearts, and it's the zebra mussel. Okay, and I highly recommend you guys look in the textbook for this. But the zebra mussel is a European species of mussel that came from on tanker ships from Europe out here. Okay, and they came over in the ballast tanks of ships, and they were first noticed in 1988, so not that long ago. According to me, not that long ago. I was 12 years old when they came over and they first noticed in the Great Lakes. Okay, so some of the Great Lakes noticed them. In 1994, so 6 years later, there was about 93,000 mussels per square meter in some areas. So imagine a meter stick and a meter stick. Imagine both of my fingers are a meter stick. In a box about that big, there were 93,000 mussels. Okay, so what do you think those did to that ecosystem? They started competing against the mussels that are native in those ecosystems, started competing against the mussels that relied or were naturally present in the Great Lakes. The scary thing is they have been migrating. Okay, these mussels have been migrating all the way across Canada. And in recent years, there have been notifications, there have been sightings of them in Saskatchewan. I haven't heard of any confirmed sightings here in Alberta, but they're getting here. They're getting here very quickly. And once they're here, it's going to be impossible to get rid of them because mussels, snails, they're very prolific breeders. If you have one, okay, they don't need a sexual partner to reproduce. They can split into two and then four. It's kind of like the coronavirus can go grow exponentially. Okay, so once they're here, that sort of sucks. And it'd be nice if they were a useful species, something we could eat or whatnot, but we can't. Okay, this is how they're coming across the country. Okay, so here is some boat propeller, which was probably docked in a lake somewhere. Okay, and over time, some of the snails or the mussels started going onto the props and whatnot, and they're stuck here. So let's say you want to take your lake, you want to go and check out some fishing at another lake. So you go and take your boat and you drop it into another lake. You turn that prop end and it starts spinning. Where do you think those mussels are going to go? They're going to start flying all over the place. Okay. Once they start doing that, boom, you have a population explosion. Okay. So us, we're the reason for it. Yeah, that's why if you actually go to Gull Lake, there's signs all over the place. Clean your boats, clean your props. You can get a pretty big fine if you don't. And that's because we don't want these things in Alberta. Okay. That is it for the presentation for topic 3.2. 3.3 was covered in when we did topic 1.2, I believe. So that talks about water quality and a little bit of algal blooms and whatnot. I'll be making out the quiz for you guys for topic 3. So you'll have to do that probably after you watch this video. I highly recommend you go back and watch that topic 1.2 because there might be a question or two on algal blooms and water quality in that quiz. Other than that, it was kind of short and sweet, maybe 10 minutes. Guys have a good one. Email me if you have any questions.